This section is going to be dealing with how to find the area of a rectangle, and the same procedure applies to a parallelogram, so we'll cover those both together. Now this, students, should be complete review for you. You should have already covered how to figure out the area of a rectangle or a parallelogram. But I want to just go over this background for you real quick, and then we'll get into some of the type of questions you will have to answer on future homework and quizzes and tests. So this is in your Intro to IM2 flipbook. This is section number 5. It is the top flap of section number 5. Please go ahead and fill in the title of this section, Area of Rectangle / Parallelogram. Let's go ahead and just do the fill in the blanks, because this is giving you some background on definitions, and then we'll go to the next section. So, area is the measurement of space. So notice it's different from perimeter. Perimeter is the length around something. Area is the measure of space inside of a two-dimensional shape. When we talk about two-dimensional, it's like something that's drawn on a piece of paper. It's different from three-dimensional, which would be a solid object like your pencil or pen or your desk, a cube, a cylinder. All of those are three-dimensional because they have length, width, and height. So area just has two dimensions, and so we only use it for two-dimensional objects or two-dimensional shapes. A parallelogram, let's define that again, something you saw last year, is a four-sided, hang on while my computer catches up with me, and it's still not caught up, hang on a sec, is a four-sided polygon. We've already defined polygon. Four-sided polygon with opposite sides which are parallel and congruent, meaning they'll never touch and they're the exact same length. Remember, opposite sides mean, well, we'll look at opposite sides in a moment. A rectangle is a parallelogram with all interior angles equal to 90 degrees. So let's look at this real quick as a reminder. A rectangle is a parallelogram. It's just a special type of parallelogram because all the interior angles are equal to 90 degrees. A rectangle has the same properties other than that, same properties as all parallelograms. Opposite sides are congruent and parallel. So let's take a look at a couple shapes just to remind us of these properties. We've got three shapes that I've drawn out here. Let's take a look at the first one. I've drawn this specifically to show you an example of a rectangle. Remember, a rectangle has all interior angles equal to 90 degrees. And remember, for a rectangle, opposite sides are parallel and congruent, and these two opposite sides are also parallel and congruent. Now, just because I took this shape and twisted it or rotated it didn't change the shape. In fact, when I drew this shape, I just copied this one and pasted it and just rotated it. So even though this is turned on its side, I want you all to see this is still, I can still call this a rectangle as long as I know that the interior angles are equal to 90 degrees, and I designed it that way. So let's go ahead and mark that. Remember, class, never assume an angle is 90 degrees unless you're told it is, or unless it has this mark on it which shows you the symbol for a right angle or a 90-degree angle. This has opposite sides again that are parallel and congruent. Same thing here. Alright, let's take a look at a parallelogram. Parallelogram doesn't have right angles or 90-degree angles inside, but we do know that the opposite sides are still parallel and still congruent. And for all three of these shapes, the area is found by multiplying the length of the base times the length of the height. And let's take a look at this first diagram. I'm going to call this side the base, small b, and I'm going to call this side the height. And over here, just because I twisted the shape, if you turn your paper sideways, you can see you can make it look exactly like that. Change its orientation. That could be the base and that could be the height. Now for both of these shapes, class, I could have called any of these sides a base. If it's a rectangle, Doesn't make any difference. That could be the base and that could be the height. This could be the base, this could be the height. What you can't do is, you can't call one side the base and the opposite side the height. They have to be two sides that are touching each other at a 90-degree angle. That's how you would do it. So you can pair up any two of these touching sides, which is called adjacent or adjacent sides. Any two of those will give you the information you need to figure out the area. Now, parallelogram is a little bit different. If we go to the parallelogram, you can see if I turn my paper so that one of the sides is horizontal, I can always call that my base. I'm looking for a horizontal side, and I'm going to call that my base. But my height is a little bit different. Now, you want to be careful here. This is not the height of the parallelogram. If I told you this was 6, the length was 6, and this length was 5, it's not 6 times 5 to get you the area. If you want to find the height, think about it like if I want to know how tall you were. If I put a tape measure up to you to measure from your feet to the top of your head, and you stood at an angle, you stood crooked, like this side right here, I'm not going to get your actual height. You have to stand straight up and down. So to measure the height of a parallelogram, we have to draw a line that is straight up and down from the base. I'll do my best to draw that line for you. In fact, you know what? Let's go ahead and just draw it a different color so we can see it, and I'll try to be a little better on that. I'm going to go ahead and draw a line, segment. Whoops, that's my wrong drawing tool. Let's try it again. Here we go. And now I'm going to draw a line that's straight up and down, if I can get it to be straight up and down. Wow. There we go. Straight up and down from the base. And to show you that, I'm going to go ahead and mark this as a right angle. If that's perpendicular or straight up and down from the base, then we know that that is an accurate measure of the height. Just like if you stood straight up and down, I could measure your height from the floor to the top of your head. All right, so this then is going to be our height, this orange line. That is our height. Now I could have measured that here, 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 here. I could have actually, if I wanted to, crazy enough, I could have actually measured the height right here if I wanted to. It doesn't make a difference. Think about it, class. We know that the base and the opposite side are parallel. These two sides are parallel. So no matter where I measure between the two of those sides, as long as I measure at a right angle, I'm going to end up with the exact same measurement. So here's how you find height and base for rectangles and parallelograms. And the area of those shapes, the space inside the shape, is found by multiplying the length of the base times the length of the height. And now let's go ahead and apply this. Question number 1, what is the area of a rectangle with vertices at A, -1, 1, B, C, and D? You see there are our vertices, and you can see there's 4 vertices. That means it's going to be a quadrilateral. And I can see when I draw these sides in, this is actually going to be a rectangle. So do that on your paper if you would. Go ahead and connect those with a straight edge again. Please don't sketch straight lines. If it's on a graph, you want to be accurate. So use a ruler or a straight edge. If you don't have anything handy, go ahead and use your student ID. The edge of that would make a good tool for drawing a straight line segment. So there is our shape. And I can tell you that these must be right angles because B is right on top of A. That's a vertical line. A and C are on the same y value of 1, so those are horizontal. So I can tell you this is definitely a rectangle. In fact, I'm going to go ahead and just write that. This is a rectangle. And the good news is they tell us it's a rectangle, so we don't even have to speculate. We know it's a rectangle. How do I figure out the area? Let's pick a side and call it the base. I'm going to call AC the base, and I'm going to call BA the height. And all I have to do now is count units, because the cool part is we've got a vertical line and a horizontal line. Don't need to use the distance formula. 1, 2, 3, 4. So this is equal to 4. And the height is equal to 3. And I know the area of a rectangle is equal to base times height. which means it's equal to 4 times 3, which is equal to 12. And I'm not given a unit of measure, so I'm going to have to just write 12 units. Put U. An area is two-dimensional, and that means the unit of measure is going to be squared. This 2 represents 2 dimensions. So it's 12 units squared is the area of that rectangle. Let's take a look at the next one. Looks a little bit trickier. What is the area of a rectangle with these vertices? And I've already plotted them for you. You can spend a few moments and plot them. And while you're plotting them, I'm going to go ahead and connect these together. If I use the correct drawing tool, I can get this accomplished. Got those 2 points, those 2 points, these 2, and these 2. Now, pause the video if you need to get that completed, and then take a look at the question. It says, what's the area of a rectangle? So I don't have to guess whether this is a rectangle or not. I know that it's a rectangle because the question tells me that. That means I know these are all right angles. And if they're all right angles, then I know that to find the area of this, all I got to do is find the length of one side. Let's call this our base. And I'll just call this one our height. If I can find the length of this segment BA, and I can find the length of segment DA, I have my base and my height, and I can figure out the area. Now, this takes a little bit of work because now you have to use either Pythagorean theorem or the distance formula or the distance shortcut. And I'm going to go ahead, for the sake of time, I'm going to use the distance shortcut. So let's figure out what the distance is between A and B. I know A is 3, 0. B is -3, -2. The distance, it's not very good. The distance shortcut method, let me get this off of here, make that a little better. 3, 2. Okay, the distance shortcut method says we subtract 3 minus -3 is 3 plus 3, which is 6. 0 minus -2 is 0 plus 2, which is 2. Now we're going to square both of those numbers. That makes 36, and 2 squared is 4. We're going to add those numbers together. That's going to give us 40, and our answer to the length of segment AB is square root of 40. Square root of 40. All right, let's figure out the height. So the height's going to be segment DA. Point A, we already wrote this down. Point A is at 3, 0. Point D is at 2, 3. We're going to subtract these. 3 minus 2 is 1. 0 minus 3 is -3. I'm going to put that in parentheses so we don't mess that up. So 1 squared is 1, and -3 squared is 9. Add these together, and you end up with 10, and then we put a square root over it. So the distance between A and D is square root of 10. Now all I have to do is figure out my final area. Final area, let's do it quickly because I'm running out of video time. Area equals base times height, which is equal to the square root of 40 times the square root of 10. Go ahead and plug those in your calculator, and you will, and actually remember, radicals we can actually combine together. This is going to end up being the square root of 400 because 40 times 10 is 400. And if you put that in your calculator, you're going to get exactly 20. And remember, we don't know the unit of measure, so it's going to be 20 units squared. And there is the area of this rectangle.